A yard stacks its pipes in a triangle. One pipe on the top row, two on the next, three below that, all the way down to 100 along the ground. How many pipes are in the stack? Counted row by row, that is 99 additions, and a slip anywhere ruins it. There is a way to get the answer in a single multiplication, no adding at all. The trick is to stop seeing this as a sum, a long line of numbers, and start seeing it as a shape you can hold in your hand and measure. Some numbers stack neatly into triangles. 1 dot on its own, then 3 in a little triangle, then 6, then 10. Each one is the one before it, plus a new bottom row, 1 dot longer. So the nth triangular number is exactly our sum, 1 plus 2 plus 3, up to n. The sum and the triangle are the same thing. Take the 1 for 5 rows. 1, 2, 3, 4, 5 dots, a staircase of 15. Adding it up by hand is fine here, but imagine doing this with 100 rows. We need the shape to do the work. Now take a second copy of the very same staircase, turn it upside down, and slot it against the first. Watch the two triangles lock together into a perfect rectangle, with no gaps and no overlaps. Count the sides of the rectangle. 5 rows tall and 6 columns wide, one wider than it is tall. That rectangle holds 5 times 6, 30 dots, and counting a rectangle is trivial. And crucially, it is made of exactly 2 of our staircases, the cyan one and its green twin. 2 staircases make the rectangle, so 1 staircase is half of it. 30 halved is 15, exactly the sum we started with. The shape just proved the answer. And nothing at all was special about 5. For any number of rows you like, the flipped copy always completes a rectangle, n rows tall and n plus 1 dots wide. So the sum from 1 up to n is simply n times n plus 1, all divided by 2. One tidy formula, straight from the picture. So the 100 is easy now. 100 rows make a rectangle 100 by 101. That is 10,100, and half of it is 5,050. So the stack in the yard holds 5,050 pipes. 99 separate additions, every one a chance to slip, replaced by a single multiply and a single halving. That is the power of turning the sum into a shape. So a long-running sum is really a triangle of dots in disguise. Instead of adding the rows one by one, double the triangle. A flipped copy turns it into a plain rectangle, and a rectangle you can measure in 1 multiply. Then halve, because you used 2 triangles to build 1 rectangle. See the shape, double it, halve the answer. A 100-step sum becomes a single line. Your turn. Add every number from 1 to 20. 20 rows, so build the rectangle in your head and halve it. Pause and try. 20 rows make a rectangle 20 by 21, which is 420 dots. Half of that is 210. So 1 all the way up to 20 is 210, and you never added a thing, you just measured a rectangle and cut it in 2. One more, a little bigger. Add every number from 1 to 30. Same shape trick, 30 rows this time. Pause and work it out. 30 by 31 is 930, and half of that is 465, a 30-term sum in 1 clean line. The story goes that a young Gauss floored his teacher by adding 1 to 100 in seconds, exactly this way. And the same triangle counts handshakes in a room, dots in a stack, even the area under a staircase. Turn a sum into a shape you can measure. So when a sum climbs 1, 2, 3, on and on, do not grind it out. Picture the staircase, double it into a rectangle, and halve. A 100-term sum turns into a single multiplication. That's all for this video.